At the beginning of this course in the first semester calculus, we were working with the geometric problem of finding the equation of the tangent line to a curve f and evaluating that equation for a particular value when we took a particular ordered pair point on the curve. Well, we found there was a relationship between finding the tangent to the curve f and the algebraic problem of finding the derivatives of the function f. Only recently we've been discussing the geometric problems of finding the amount of area between the x-axis and a curve, a positive curve for instance, and we just have discovered that there's an algebraic relationship to this geometric problem, and that would be the problem of finding integrals. Definite integrals is what we've been working on. So these are two different ideas. A, tangent to a curve. B, area under the curve. Now the question is, can these two ideas, A and B, possibly be related to one another? And the answer is yes. Isaac Newton had a professor, and his name was Isaac Barrow. And the professor, was the one that found the connection between these two ideas, idea A and idea B. And the connection that he found between the two of them is that the two, A and B, are inverse processes of each other. What does that mean? Well, think about it. What is an inverse function? An inverse function is one that when it's applied to its inverse, a function applied to its inverse undoes what the inverse did. An inverse applied to the function undoes what the function does or did. So the inverse process of one another, in other words, this association between these two ideas, A and B, it has a name. It's called the fundamental theorem of calculus. It expresses the way that if we are speaking in geometric terms, the tangents to the curve is related to the area under the curve. In other words, it demonstrates the inverse process of one another between finding the derivative and finding an integral.